Hello, in this video, we will talk about how to use R to carry out classification with decision tree algorithm. So in the decision tree is a type of machine learning technique, and this is to model the algorithm as a tree structure. So breaking down from feature and with a question or with some criteria for the continuous variables to break down to the leaf node. So if, for example, we ask a question yes or no to come here, and here can be very significantly to classify yes or no, or two classes or three classes. So we stop it here for this node. So this is the leaf node. And for the other way, if it's not pure enough for each label classes, so we will go further down to ask other questions, or for the continuous features, we will make criteria for other road. So we come next leaf node. These two finished because here is very pure. So we stop there, but this node is not pure enough. So we will go further and so on. But usually, if you have many nodes for the leaf, for the question node, parent node, and child node, then the tree will come to 100% pure classes for each node. But this is what we not want to, because this will get overfitting for the training data and may not work well for the new data. So usually, for classification with decision tree, we will restrict the tree number to a limited number, not need to get 100% pure classes for each leaf node. Maybe 95% correct is okay, like this. And for criteria for selecting which feature goes down in each step, based on a criteria called maximum information gain. So information gain is the difference between the parents I. So we call I here is the impurity. So impurity means, for example, we have 100 observations for this node, and 40% and 60% are different two classes. So this is quite not pure, right? If we have 50% one class and 50% other class, so this is not pure. But if we have 100% or 99% one classes and 1% other classes, so this is significantly pure. And this measure called impurity measure. So we will go down for each feature and criteria based on which point, which node for the feature we can get maximum information gain between the parent node and the child leaf node. And this is the number of observations for each leaf. So the summation is same as how many observations in the parent node, right? So this is quite understandable. So we get a maximum information gain for this node with this feature. Then we will go down. Next step, we will choose other nodes which will get the maximum information gain. And information gain is the difference between the parent node's impurity measure and the child node's impurity measure together. And for calculating the impurity measure, so this is the basic formula for the left node, right node, right? Information gain. And for calculating the information gain, we will know impurity measure. So impurity measure, one of them, the most widely used, is called entropy. So entropy is negative of the sigma. This I from 1 to C is for the classes. So for example, in this leaf node, we have two classes. How many observations belonging to one class and how many belong to other class? So for example, this is in the two classes case. So for example, 90 in one class and 10 in other class, then we will calculate the probability. So 0.9 is one class and 0.1 is the other class. So we will sum together for each class with this form. So P log P. So p log p. P log p with 0.9 then times log 0.9. Because the probability of the log is negative, so we use negative here. So the total summation of this format called impurity measure, entropy. And this entropy is positive. Entropy is positive. So entropy from 0 to 1. Entropy from 0 to 1. If entropy is 0, it is 100% pure. And entropy is 1, it is 100% not pure. So the impurity higher, the entropy is higher to maximum 1. So entropy is between 0 to 1. We look at this plot. For example, in two classes case, if one class has 0.5 for the probability and other class also 0.5 probability, because for 100 observation we have 50 for class 1, 50 for class 2. So both have 0.5 probability. So from the formula for the entropy, we will get this entropy is 1 because it's not pure, 100% impure. So this entropy is 1. But if 100 case, 100 belonging to only one case and 0 belonging to other classes, so its entropy is 0 because it's pure. So its impurity measure is 0, is the lowest, right? So we will go down from the tree, from the node to node, based on the we will maximum its difference between the parent's entropy and the node's entropy, child entropy, right? So this is the criteria for this algorithm for classification. So next we show how to implement an example for decision tree in R, and you can download this source file from this link. And we also have a website for R and Python training on weekend. This is a paid course for 2 weekend days, about 8 hours, and currently the price is $3, and we use Zoom for video training. So next we go to RStudio and open this file. So here we set a working directory because we will load the file later, and this code shows how to plot this entropy for different values with p. So you can see this is the entropy curve for the probability for the binary classes case. Then we read this file called credit, and we show the structure of this data frame. So this credit is a data frame with 1000 observation and 17 variables. So these variables are all for the bank, for this client in the bank's information. For example, how many saving balance and the purpose for the loan and the credit history, like this. And here default is for if a bank provide the loan or not provide the loan. So there are no yes. Yes is good, no is not good here. But this is not important because there are only 2 cases. So we show the several variables in this data frame. For example, this checking balance, 1, 2, 3, 4. How many cases? Total 1000. And for saving balance, this is 5 factor levels. So these are factor variable because we read this file use default. Oh, sorry, because this R is new version, so not factor, but this is not important because R will use table no matter it's factor variable or not factor variable. Just use category, they will take as category. And we will summarize some continuous variables. So continuous variable will show the 5 statistic point, minimum, maximum, and first quantile, median, and mean, and third quantile for these variables. So this is the class variable for the default. So we show 700 no and 300 yes. This is for from the total 1000 observations. Then we will take training data. Here we set the seed and for the random variable generation and create a random number, 600 random number from 1 to 1000. We will use sample function because this index will be used for training data's index. So this is 600 integer number between 1 to 1000. So we used this index number to get the training data and the test data. So test data is the other 400 observations. We use the minus sign here. And these two will show the proportion of two categories if it matches in the training data, test data with original total data. So you can see they're very close to 7%, 70% and 30%, right? In the training data, and for test data is also very close to 70% and 30%. Then we will load a library called C5J because this is for the classification algorithm, and you have to install this library first, install this package first. And here we set X factor because the dependent variable or the default must be factor variable, because in the new R version after R40, factor a string as a factor option is not default true, so we have to manually transform these two variables as factor variable. Then we create a model called the credit model, and using this function C5.0, then we use all the 16 variables for the selecting features, and this for the class label for the dependent. So the model is run, and we show the summary collected model. Total tree size 23. Then we show the summary of this model. So this summary shows very big information for each parent child node. For example, they will show this is a question for this total tree feature selection, and at the end of this summary, show this confusion matrix. So confusion matrix is for this is the tree class and this is classified. So for example, tree class, the real class is no, and it's also classified as no. So this is correct. And if the real class is yes, and it's also classified as yes, so this is also correct. But these two are error or incorrectly classified. So there are about 100 cases in the training data. So from 700 observations, there are about 100 examples wrongly classified. And we show the model, how to use this model to predict for the training or for the test data. So we use predict this model and for the test data. And for the test data, we will manually print this confusion matrix. So for the test data, 400 observations, there are about 27%. The total, these two are only about 108. So about 27% of 400 observations are wrongly classified. So next we can improve a little bit the model using trials 10 here option for this model. So we set trials 10. Then we show this model about 23. Then the summary of these model results, we move up. So now it's largely reduced. About only 47 cases from these 700 training data are misclassified. And similarly, we will use this new model to predict for the test data, and we show also the confusion matrix for this test data. So now it's about 25%. So for the test data are a little bit better than before, because we in this case we have only 1,000. Maybe this is not enough data, so the reduction of the misclassification in the test data is not so big, but anyway it's better than before. So we just stop the running of this case here, and if you are interested, you can download this code file and check every code statement. Thanks for watching.